A Carnot engine has an efficiency of 20%. The temperature of sink is reduced by 80 degrees centigrade. Its efficiency is doubled. The temperature of the source is. So we know that if the temperature of the source is T1 and if the temperature of the sink is T2, then the efficiency of a Carnot engine will be given by 1 minus temperature of the sink divided by temperature of the source into 100 if you want to express in percentage, right? If I want to express it in percentage, so we should multiply with 100. So according to the question, the Carnot engine has an efficiency of 20%. So 20 will be equal to 1 minus temperature of the sink divided by temperature of the source into 100. This is our initial situation. Now question says that when temperature of sink is reduced by 80 degrees centigrade, its efficiency is doubled. So that means finally the efficiency becomes double when the temperature of the sink is reduced by 80 degrees centigrade divided by temperature of the source into 100, right? So from here we can say that 1 minus temperature of the sink divided by temperature of the source will be equal to 20 by 100, right? And from here we can say that 40 by 100 will be equal to 1 minus, if I divide this whole both thing with the temperature of the source, so we can write temperature of the sink divided by temperature of the source plus 80 divided by temperature of the source. We can break it like this, and this is the value of 1 minus temperature of the sink by source, 20 by 100. So we can replace it here. So we can write 40 by 100 will be equal to 20 by 100 plus 80 divided by temperature of the source. So by this we can say that 80 by temperature of the source will be equal to 20 by 100. So we can say that temperature of the source will be equal to 400 Kelvin. But our option is in degree centigrade. So 400 Kelvin can also be written as 127 degree centigrade, right? So we can say that our option number 3 will be the correct choice. Now let's move to the question number 37. Question number 37 says that cooling of water under atmospheric pressure is, and we know that atmospheric pressure is always constant, it never changes, right? So if the atmospheric pressure is always constant, so we can say that cooling of water is an isobaric process. So my option number 2 will be the correct choice, right? Let's move to the question number 38. Question says, in an adiabatic expansion of an ideal gas, select the incorrect statement. Again we have to choose the incorrect statement. So we know that in adiabatic expansion, volume and temperature to the power gamma minus 1 will remain constant. So we can write volume will be inversely proportional to the temperature to the power gamma minus 1. So since this is a expansion, so we can say that volume will increase. So if the volume will increase, so we can say that temperature will decrease, right? So first option says there is a decrease in temperature of the gas. So this is a true statement. And we know that when temperature decreases, the internal energy of the gas will also decrease because it completely depends on the temperature. So second statement says that there is decrease in internal energy of the gas. So this is true statement. Work done is positive. So we know that if the volume increases, the work done will be positive for the expansion. Volume increases, and if the volume increases, the work done will be positive. So this is also a true statement. Fourth statement says that work done by gas is equal to heat supplied. Since it is an adiabatic process, so heat supplied will be 0. So this is a false statement. So our option number 4 will be the correct choice. Now let's move to the question number 39. Now question number 39 says, an ideal gas has initial volume V and pressure P. To triple its volume, the minimum work done will be in. So basically, we are expanding. We are increasing the volume. We are making triple its volume, right? So if you guys can remember the graph of PV for different processes. So if you remember, if you draw the graph of pressure versus volume for an expansion for different process, so we know that for isobaric process the pressure will remain constant. So this is the graph of isobaric process, right? For isothermal process the slope will look like this. This will be rectangular hyperbola, right? So isothermal process will be this. And but for adiabatic process slope will be more. So the graph will be little bit more curved. So this will be our graph of adiabatic process, right? So this is the graph of isothermal, adiabatic and isobaric when the volume increases from V to 3V for the expansion, right? So these are the processes, graph of the process. And we have to calculate the work done. So work done is what? Work done is area under the graph. So as you can see that the isobaric, so this isobaric will have the maximum area, isothermal, but the adiabatic will have the least area. So we can say that our work done will be minimum in adiabatic process. So option number 2 will be our correct choice. Now let's move to the question number 40. In question number 40, it says that an ideal gas of adiabatic exponent, that is gamma is equal to 7.5, is expanding at constant pressure. The ratio of dq, du and dw is. So since it is expanding at constant pressure, right? So we know that at constant pressure, dq will be how much? At constant pressure, dq will be equal to n Cp dt, right? And what is the value of Cp? So we know that the Cp will be equal to R into gamma upon gamma minus 1 into dt. So gamma is 7/5. So we can write nR dt into 7/5 divided by 7/5 minus 1. This is our dq. So by solving this, we will get 7/2 nR dt. This is our dq. What about du? Du can be written as, for isothermal, adiabatic, whatever be the process, du is always equal to nCV dt, or you can write nR dt upon gamma minus 1. So again, what is the value of gamma? So if I put the value of gamma, we will get 7/5 minus 1, that will be equal to 5/2 nR dt. This is our du. Now what about dw? So dw for an isobaric process, that is constant pressure, the work done will be pdv, and since pressure is constant, so pdv can be written as nR dt. So this is our dw. So we know the dq, we know the du, we know the dw. So if I write the ratio dq is to du is to dw will be equal to, since nR dt is same, so we can write 7/2 is to 5/2 is to 1. So we can little bit rearrange it. We can write 7 is to 5 is to 2. So this is our ratio. So by this we can say that our option number 4 will be the correct choice. Now let's move to the question number 41.